Hello, everyone. Welcome to Optimizing Amazon EFS for Cost and Performance Using Best Practices. My name is Sean Khan. I'm the Principal Solutions Architect for Storage, and I work for Amazon Web Services. Today, we will be discussing what Amazon EFS is. We will also talk about some of the use cases that many customers use EFS for. We will also dive deep into how many customers optimize the use of EFS for to reduce their cost, and also look at some of the performance best practices that we see customers adopting to optimize for performance while they're using Amazon EFS. And after that, I will also talk about a few customers that have successfully adopted and leveraged EFS to optimize their workloads within AWS. And then we will quickly go into a quick call to action around what would be the next steps and how you can take advantage of EFS and test it out. So with that, we will start with what is Amazon EFS. So simply put, we launched Amazon EFS in 2016 to provide customers with a super simple file system that they could leverage to house their shared file storage data. And it's a fully managed cloud-native NFS-based file system. And you could get it up and running within a few minutes and then start taking advantage of all the elasticity and the scalability that comes with this file system. So many customers leverage EFS and they don't have to pre-provision capacity. So elasticity is built into the service itself, where you only pay for the capacity and performance that you use for. So basically, you don't have to go pre-provision resources to be able to take advantage of the performance and capacity capabilities of the file system. And EFS, as I said, is elastic and it automatically scales up, which basically means you don't have to constantly increase the size of your file system. As you add data or files into your file system, it will automatically grow. And when it grows in capacity as well as in performance. So the more data you're hosting on a file system, the more performance it will automatically provide to your workloads. So with elasticity and scalability, since you don't have to necessarily increase the file system size every time you see growth of your data, it automatically scales up. And in addition to that, it could scale to petabyte scale. So you don't necessarily have to create multiple file systems or namespaces. You could scale the single namespace to many petabytes using EFS. And with scale, it also comes with high availability and durability. So EFS has 11 nines of durability, and it also provides our customers with 4 nines of availability while we are protecting customers' data, and it's highly durable, as I mentioned earlier, and then it's protected across multiple availability zones. And because of that, if there is an event where one availability zone is not available, you will not see any outage or you will not see any loss of access to your file system, and your workloads will keep performing as if nothing has happened. So with that, since this is a scalable and serverless shared storage, and you don't necessarily need to keep track of the IOPS, you could also scale the performance by pointing multiple instances or multiple servers or multiple workloads to the file system, and that's how you can scale for performance as well as by adding additional data onto the service, you could scale for capacity. While we're talking about performance, you could have tens of gigabytes of performance out of a single file system, and you could scale up to 500 plus thousand IOPS per file system. And we will also talk about different classes, and there are two different storage classes that Amazon EFS has. The first class is the EFS standard class. We will talk a little bit about that in a few minutes. And then the second one is for cost optimization, EFS infrequent access class that allows our customers to scale as well as keep their costs to a very manageable number. And in many cases, the customers are able to save on the cost upwards of 80 to 90%. And I will share an example of a customer who was able to actually reduce their cost of a self-managed file system by 90% by leveraging Amazon EFS with the lifecycle policies that I'll go into detail in a second, and by using infrequent access. And since it's a single namespace, you don't necessarily have to create multiple file systems to be able to do the transition. Amazon EFS service does all of that for our customers, where you have a single namespace, and that namespace will scale to petabytes for your workloads. And again, it provides our customers a shared access where you don't necessarily have to pre-provision and then manage multiple file servers. You could share data across many EC2 instances or many machines or many users or many consumers in a very manageable and almost a self-service manner. And with scalability and having different storage classes, the EFS has achieved many compliance certifications. So, for example, SOC, ISO, PCI, DSS, HIPAA, FedRAMP, and so on and so forth. EFS offers transparent encryption at rest and in transition, and integrates with our cloud-native controls like VPC, IAM policies, and for access management. And you could easily manage applications across a large scale with EFS access points as well. So now I'm going to talk about some of the use cases that we see many customers leverage EFS for. We have designed EFS to serve a vast majority of workloads, and mainly file-based workloads. And we have many customers that leverage EFS for their Linux-based home directories, for their serverless or container storage, for persistent storage. Many customers use that for their application testing and development environments, and just as a general purpose NFS-based file system. So many media and entertainment workflows run on EFS, as well as applications like big data applications. They run on EFS, and they leverage EFS as a persistent storage for those workloads. So now I'm going to dive a little deeper into cost optimization best practices. This is where I'm going to show you how you can optimize your spend on EFS and get a highly durable and scalable and highly performant and secure file system. So let's talk about some of the, so there is no minimum upfront commitment for EFS. So basically you don't have to pre-deploy the infrastructure or pre-deploy the capacity for your use. You basically pay for what you use, and you don't need to pre-provision any storage in advance. So in addition to high availability and durability, the multi-AZ architecture of Amazon EFS enables use cases, especially with spot instances, where having a persistent layer of storage enables many workloads where if a spot instance or a fleet of spot instances used for a specific use case or a workload, EFS fits really well and helps our customer reduce their compute costs by upwards of 90%. So EFS, since it supports the lifecycle management policies, you can lifecycle your cold data or cold files to the infrequent access tier to reduce your cost by upwards of almost 80%. So now, since we talked about infrequent access and what exactly that infrequent access enables our customers with, So with infrequent access, a combination of infrequent access and standard class enables our customers to basically get the best of both worlds. So where you have customers can have performance, the workload or the data that requires high performance, especially for small files or any metadata intensive operations. Customers can use standard EFS standard class, and for all the data that's not necessarily accessed all the time, customers can use infrequent access. And for example, if you look at a blended cost of infrequent access and the standard, customers have reduced their spend on EFS to only 2.5 cents per gigabyte. If you look at the overall blended storage cost, it's about 8 cents per gigabyte, which is pretty good for a general purpose file system. So the way its standard and frequent access class and lifecycle policies work is that the data is actually migrated in the background from EFS standard class to EFS infrequent access. And according to the lifecycle policies, you can set them anywhere from 7 days to 90 days, depending on what your workload profile or your workload needs are. On the performance side of the house, EFS infrequent access has a slightly higher first byte latency as compared to the EFS standard class. And you'll see on average single-digit millisecond latencies with EFS standard and typically double-digit latencies with EFS infrequent access. So with that said, you get pretty much the same level of throughput against files in infrequent access as files in standard tier. So the baseline throughput is used typically to calculate your burst credits and your burst rate, and it also is used to calculate the amount you'll be actually billed for when you're using provision throughput. So infrequent access, so typically when we look at the access patterns and how costs are metered within a file system, we see that with standard storage, it's metered in increments of 4 kilobytes. Reads from EFS infrequent access and lifecycle transition to EFS infrequent access are metered in 1 megabyte increments. So there's a lot of flexibility where customers can leverage a combination of standard and infrequent access to reduce their cost for shared storage within AWS. So here is an example of a workload that has lifecycle management enabled, where you look at pay-as-you-go cost for effective storage. You can see it's about 8 cents per gigabyte per month, where the general purpose file storage is about 30 cents per gigabyte per month. And as it's transitioned into infrequent access, storage class, you'll see that the cost optimization comes into play, and when the files that are not accessed based on your lifecycle policies, the bill basically goes down for that storage tier. So the more workloads or the more files that are not really accessed a lot, they will go into infrequent access, and the more customers end up saving as far as the cost is concerned. So now we will look at performance optimization best practices, and I will actually share a few of the best practices that I have personally seen customers run into in the past. And if they were to optimize the use of the service from day one, they would not have seen or run into some of those issues. So before I go into some of those best practices, I want to talk about how performance is optimized and different, basically different ways you could provision for performance. So there are two performance modes within EFS. There's general purpose, which basically is the default. It typically is leveraged for low latency or latency sensitive workloads, and whereas max IO is typically used for large scale and data heavy applications. And what are some of the advantages? So advantages of general purpose, again, it's general purpose, so it's fit for a larger type of workloads that require low latency for file operations. And max IO is typically used for scale out applications or applications that need scale out performance. Some of the trade-offs. So the trade-off for general purpose is that there's a limit of 35,000 file operations per second. And the trade-off on the max IO side is that there is a slightly higher latency for metadata operations. So we recommend that customers, when you know that you're going to have a lot of small files with a lot of metadata operations, it's better to get a blend of general purpose and max IO EFS performance tiers or performance modes. And when to use that, basically general purpose is typically the starting point for many of our customers. And as the workloads grow and for large scale workflows and workloads, max IO is the recommended performance mode. And now we will look at the throughput modes. So we talked about the performance mode. Now there are two different throughput modes. Bursting throughput is the default mode, which again is recommended for majority of the workloads. And then provision throughput is recommended for workloads that customers already know what the workload performance profile is, and they will, the workload or specific applications will require consistently higher throughputs for those files. And in that case, provision throughput is a better choice. And so some of the advantages, we talked about auto scaling of throughput. So burst throughput automatically scales based on the capacity. As your data grows, your burst throughput credits grow with it. And advantages of provision throughput is if the performance requirements of your workload are known, then it's better to provision the throughput so you don't have to worry about running out of your burst credits that would renew after a few hours. And some of the trade-offs, fixed throughput to storage ratio. So basically, as your storage grows, your burst throughput grows. Whereas with the provision throughput, there's a separate charge. Since it's provisioned, it's I would say pre-dedicated type of throughput to your workload. There is a separate charge for provision throughput mode. And when to use that, again, as I said, it's burst throughput is the default. So it's typically used for general purpose file services workloads and pretty much all the other general purpose NFS type workloads. Provision throughput is typically used for throughput where throughput is typically, the requirement for throughput is much, much higher as compared to the capacity requirement of that file system. So for example, if you have a file system of 100 gigabytes and you need an X megabytes or gigabytes of throughput, and you know about that requirement, it's better to use the provision throughput and pre-provision that throughput. So you don't see any performance issues while your workload is running in production. So now coming to some of the additional best practices. So there are different ways where we could optimize performance. So looking at the client side, we recommend they use Amazon EFS Mount Helper to automatically get the recommended mount settings because they're optimized for best practice and best performance as well as data integrity. And we recommend you always use NFSV version 4.1 over 4.0 because the 4.1 clients are more stable and more performant than 4.0. And again, use the most recent kernel because the recent kernels have several NFS client improvements. And the last one is the one that I've seen many customers run into, especially when they're testing out EFS, is by going directly to a mount point and not using DNS name to mount. The issue is when you, or I should say, to avoid an issue, we recommend that you use the DNS name to mount on EC2 instances because that resolves to the IP address of the Amazon EFS mount target in the same availability zone as your Amazon EC2 instance. And by doing so, you avoid any unnecessary data traffic charges for your EC2 instance across availability zones, as well as you reduce the latency that you may end up seeing if you're going across availability zones. So if your storage is sitting in a different availability zone away from your compute, there's going to be additional latency. So if you use the DNS name to mount the file system, you will always get the availability zone where your EC2 instance is hosted or is located. So that helps reduce many of these initial pitfalls that I've seen customers run into, especially from the NFS client side. So small file optimization again, choose the performance mode, general purpose or max IO. So just like I said earlier, general purpose is best for lowest metadata latencies and workloads where IOPS are typically around or less than 35,000 reads and about 7,000 write operations. So, and we recommend you use max IO for higher throughput and IOPS, keeping in mind that higher throughputs will definitely help, but there is a caveat there with higher metadata latencies as well. So, okay, and then again, it's best practice to multi-thread your operations, parallelize your I/O with the maximum concurrency of about 40 per instance. So when you saturate the IOPS for a single instance, it's best practice to move to multi-instance deployment to get the maximum IOPS possible, and use multi-AZ, and you're using multiple AZs in the back end as well. So for throughput optimization, as I mentioned earlier, it's important to know when to use which throughput type. So typically burst mode is used for large file systems to get higher throughput. And when you're looking at the throughput in burst mode, typically we see, for example, here, base rate would be about 50 megabytes per second per terabyte of storage, and bursting rate would be 100 megabytes per second with a minimum rate of about 1 megabyte per second. And for provision throughput, you could go to up to tens of gigabytes independent of the file system size. We also recommend they use large I/O size to optimize for performance. We've actually recently doubled per client throughput from 250 megabytes per second to 500 megabytes per second, and you could basically scale it as you add more instances. Some of the other optimizations, basically adding a file to a directory, as we know, is a synchronized operation. So spreading out files over a large number of directories always helps. And for monitoring, it's a good best practice to monitor the percentage I/O limit as well as the burst credit balance to make sure that you are provisioned correctly, especially on the base throughput when you're looking at some of the burst performance capabilities or availability of burst credits. So now I'm going to quickly talk about a couple of customers who were able to leverage Amazon EFS to optimize their storage cost as well as their operations within AWS. So here, as we know, Discover is a global financial services company, and they produce Discover Card, Diner Club Card, and many other financial products. So Discover has multiple lines of business that utilize analytics and gain insights into their business, and basically collaborate to across multiple teams to basically enhance the products and services that are offered by Discover. So in this scenario, they had about 500 data scientists that were performing analytics on their data, and the issue that they ran into on premises is because they weren't able to really, since these workloads were more spiky and unpredictable, they were not really able to meet the demands of their data scientists in time. So they started investigating, and they came to us. They came to AWS, and then we helped them design and architect an environment that was able to scale and meet their needs and meet the needs of their data scientists. So we were able to give them the scalability and security and the durability as well for their workloads. And basically, we were able to enable all 500 data scientists at the same time, and they were able to add more data scientists as they matured and as the solution grew. So the problem that they were initially running into were the fluctuation in demand. And what they did initially, they went for do-it-your-own-self type of shared file system using an EC2 instance with third-party storage management software on top of that. What that did, that basically added additional operational overhead for them. It was really difficult to scale. They had to pre-provision resources, and basically it became a really expensive and complicated solution for them. So that's when they engaged with us, and they started testing out Amazon EFS, and they started liking that solution, and they started leveraging EFS to gain additional efficiencies and improve their time to value, basically. So while leveraging EFS, when they compared the cost of EFS versus their do-it-yourself shared file system, they realized that they were able to reduce their cost upwards of 80 to 90%. So that made the customer very happy, and now they're a happy EFS customer. Another example is Ancestry.com. And they're a leading provider of family history services and consumer genomics. So the challenge that they ran into were that their genome analytics processes to the cloud. They kind of wanted to make sure that they get on-demand compute, as well as they can scale the frequency and speed of their experimentation. So their genome analysis processes are characterized by spiky, unpredictable workloads, which require them to scale compute and throughput quickly, then basically tear it down and then do it again for another ad hoc request. So they were using an on-premises NAS cluster, which was very inflexible and didn't allow them to fulfill those ad hoc requests and then do experimentation fast. So what they did, they came over and they tested out Amazon EFS, and they really saw the value of EFS and the capabilities of Amazon EFS, where they initially had a mandate to migrate all of their workloads off of that on-premises NAS cluster in 6 months. With the efficiencies and our support, they were able to migrate all of those workloads into EFS within 5 months. And some of the benefits that they shared with us were increased productivity, where their IT team no longer had to spend time to fix and maintain that on-premises storage cluster. It helped them improve their agility, where data scientist teams can now quickly spin up the resources required to perform their analytics job, therefore improving their ability to perform experimentation very quickly. And ease of migration was another benefit, where our native tools were able to accelerate that migration process for Ancestry.com. Now, a quick call to action. We recommend many customers test our solution out. And then first question I typically see customers ask, so how do I migrate a test workload to test out Amazon EFS. We actually have many other tools that enable or services that enable our customers to do the migration. The one that we typically recommend, Amazon Data Sync, is a service that allows our customers to do an online transfer from their on-premises NFS-based file system to EFS within AWS. And by doing that, you can test out how your workload or your workflow, how will it behave if you run it within Amazon EFS file system. And then you could test out the security capabilities, the scalability, the cost, the performance, and all the other things for your own specific workload to make sure that Amazon EFS is the right fit for your workload. With that, some of the other best practices while you're doing the migration are to first one is to make sure that you switch to provision throughput mode for a large data set. Because when you're actively migrating, there is additional write I/O that's going to the file system, and then also architect to keep the quotas and limits in mind. And again, those quotas and limits can be increased if they're not adequate for your use case. And with that, we have additional sessions on EFS. I highly recommend that you go and attend those sessions and get more information on how Amazon EFS can fulfill your needs and help you with your cloud journey. With that, thank you so much for your time, and hopefully we'll see you soon.